Alright, once again, I apologize in advance. My voice is a little bit gone, so I'm going to try to keep this short. So we basically have these instructions, and we are essentially finding the area of this shape. So we're going to be using something called the shoelace formula. Just Google it, and then you can find like a lot of nice reading on it, and I'll try to explain it a little bit more. But here, let's go ahead and start implementing it. So first things first is we're going to go through every line in our input. So for DL color in L dot split for L input dot split lines. And if I just go ahead and print like D and L so I can show this. And also I do have one extra test case. So let me just show it so it's not confusing. It's just like a little square just for debugging for my own case. But here you can see we're reading the input nice. All right, so now from this, we're gonna actually go ahead and create a class. And hopefully it makes sense in a second why I actually choose to do this. But basically, we're just going to store all of the endpoints of our shape, and then also our perimeter. So for this, we'll have our self.perimeter is equal to 0, self.points is going to be equal to a list, currently including our start point, just because you'll see the reason why it just makes our code kind of nicer. And then self.pause, our current position. So we're starting at 0, 0. And then def, we'll add something to add an instruction. That's going to take in a direction and a length. And then here we're just going to have a hard-coded mapping of all of the directions. And so, to save myself a little bit of time, I'm going to go ahead and replace it with the code that I currently have. And so now, this is basically the code to parse our points out. So first of all, our perimeter is easy. We just add our length, whatever that is. And then now, our direction is going to be whatever we parse from our dictionary that's hard-coded with the values. And now we are going to move basically our point based on our direction. And I actually am not using complex numbers for once. I actually was originally, but it was just a little bit of a pain, and this makes the math a little bit cleaner. So, and it makes the code a little bit more followable, so that's what I have. But here, what this is all doing is I'm basically just going through and adding all the points if I follow the instructions. Let's go ahead and create our solver now. So P1 is equal to solver, and then P1.add instruction, and we're going to add our direction, which is going to be D, and then our length. And I want this as an integer, so we'll return int L. So let's go ahead, print out P1.points, and maybe it would help if I spelled it right. Let's see what we get. Cool. All right, so you here on this test case, we can see these points. And notice how we start and end at 0, 0. That is deliberate. And then here for my little test case where I just go in a little rectangle, we do see all of our points also. Cool, so we can start going on and actually calculating the area. So we'll do def solve. And so the way we're going to do this is we're going to have an area variable, and then I'm going to write this line and I'll explain it in a second with like a graphic and all that. Points. This. I hope I didn't misspell anything. And area plus equals. And then here. Alright, I'm just going to write down all the code. And then I'll explain it in a second. So, alright, so now, just to make sure that I'm not insane, let me make sure that this is currently the right code. So P1.solve, and let's see what we get on our test cases. Cool, 25 and 62. And if I submit it, all right, cool. I'm getting the right answer. So let me go ahead and explain this code. So we have all of our endpoints here. So if I take, for example, this case where I get, let me get rid of this, and then print P1.points here. So if I have this test case, all of these points correspond to all of these endpoints here. And so what I want to do is I want to find all of the kind of areas of each trapezoid from each set of 2 points. So let me explain like what I mean by that. Hopefully this works. I'm going to pray to God that you can see my drawings. But we start off here at this point, and then we have this point right here. So all of our points are added in order, all of these endpoints. And so from this shape, if I want to find the area, I'll just iterate over every 2 pairs of points and add the trapezoid I get from it. So for example, I'll do like a little bit of a simpler example with a weird shape. If I could make up my mind here. All right. So what I'm doing is I'm essentially, I wonder if it's highlighter, nope. All right. So what I'm doing is when I have something like this, if I change the color so it's a little bit easier to see, let's say I start at this point and I'm going around my shape this way. So between these 2 points, if I draw a trapezoid like this, I'll count this as my area. And then now I'll get to the next 2 points. Between these 2 points, so I'll just draw these rectangles. Between these 2 points, I am going backwards now. And so I actually subtract away this area. And then between these 2 points, I'm adding this area. Between these 2 points, I'm subtracting all of this area. And then between these 2 points, I'm, again, since it's going backwards, subtracting this area. And I end up with a negative value. So that negative is the reason why I have, first of all, this absolute value. But second of all, I'm basically going through and adding up all of these little components. And so the nice thing is they actually end up canceling out if they are not part of the shape. So if I go ahead and annotate on this one. So when I'm, for example, adding this into my shape, it's including this entire region. But all of this is not part of the shape. But that gets removed when I have this part in. And because they're going, like one is going from right to left and one is going left to right, that's why they're canceling out with each other. And it actually ends up kind of working out really nicely. Like for example, this entire thing contains the shape. And then this section that shouldn't be included gets erased by these 2 points. This section gets erased by these 2 points. This section gets erased because all of this gets removed. And then this gets added back. And so all of this ends up really canceling nicely. And so the only thing we have to next do is we have to divide by 2 because all of the positive areas do get counted twice. So if I look at my code, I'm dividing that area by 2. And the only problem is if I just go ahead and comment this out here, when I run on my test case, like for example, you can see on the test case where it's basically a square of like 4 by 4 by 4, but because just how it works, it ends up being a 5 by 5 square. We're basically not counting half of our parameter area. And so this is a little bit of just like trial and error. But with this simple test case, if I count up my parameter, and if I divide it by 2 and add 1 to it, I end up getting the right value. And it works on both test cases, and it works on my solution. So yeah, that's basically how we do like the shoelace formula in this case. And so that's my part 1. And then so for part 2, we're basically just parsing out these instructions to do something slightly different. So let's go ahead and create a new solver. And here we can go ahead and do p2.solve. And then now, what we're going to do is we want to, so here, if we look at this, based on our colors, we're doing something. So the first 5 digits should tell me the length. The last digit should tell me what the direction is. So let's go ahead and add that direction first. So that comes from just hard coding it. Here. There. So now we have those directions. Let's go ahead and actually parse out these things. So length is going to be equal to, and this is a little bit of trial and error again, but this gives me the first 5 characters from the string, and then the direction is equal to color at -2. I print out length direction. You can see this is running on that test case. You can see that I'm reading kind of this stuff nice. So if I see here, 7 ends with 7-1, and here's 0. 7 ends with 7-1, and here's the 0. So I'm reading that right. All right, so now all I have to do is just p2 add instruction. So the direction is just the direction because I'm handling it as a string. And then the other one, I'm just going to read as an integer, and I specify base is equal to 16. And so I'll just keep this in for readability. Now, for my part 2, you can see we get this value. If I look at here, this is the exact same test value. So I'm just parsing the input, passing it into the exact same algorithm. Now, if I submit my code, same solution.